Hey, Global Impact, it's Mr. Ellinger here. This lesson is on direct variation. Our learning target for this lesson is we need to be able to write and interpret direct variation equations. Some essential understanding for you in this lesson: some quantities are in a relationship where the ratio of corresponding values is constant. The formula y divided by x, y over x equals k, says that the ratio of all output to input pairs equals the constant k, and we call that the constant of variation. Some background for this lesson: direct variation functions have equations of the form y equals kx, where k is the constant of variation. These functions are a subset of the more general linear function y equals ax plus b. The graphs of direct variation functions always pass through the origin. Many physical phenomena exhibit direct variation. Examples include rates such as miles per hour, miles per gallon, cost per pound, and so on. Why do you think these are direct variations? We address this at the end. And there are other types of variations that we'll look at in future lessons. All right, so some quantities are in a relationship where the ratio of corresponding values is constant. We can write a formula for a direct variation function as y equals kx, or y over x equals k. So, and these two forms are going to be useful depending on what it is that we're trying to do. Sometimes we may be asked to find the constant of variation, and that's k. And if we are asked to find that constant of variation, a lot of times we will know y and x. And so we just need to set up this ratio, do the division, and determine what k is. Sometimes we'll have k, and maybe we'll have an x value, and we have to find the y value that goes with it. It just kind of depends on the situation. So k is not going to equal 0. X represents input values and y represents output values. The formula y over x equals k says that except for 0, 0 at the origin, the ratio of all input-output pairs equals the constant k, also known as the constant of variation. So let's take a look at a couple examples here. For each function, determine whether y varies directly with x. If so, what is the constant of variation in the function rule? So in A here, we have some ordered pairs: 1, 2, 3, 6, 4, 8. So what we're going to do is we're going to look at the ratio of y to x. In our pairs, we have 2 over 1, 6 over 3, and 8 over 4. And all of those ratios are equal to 2. So we would say that yes, y does vary directly with x because there is a constant ratio here between output to input. The constant of variation in this case is 2. So then we could write the function rule that says y equals 2x. The y values are twice the x values. That's the rule. All right, so here in our second example, in part B, we have when x is 1, y is 4. When x is 2, y is 8. When x is 3, y is 11. So if we look at our ratios, y over x, we have 4 over 1 equals 8 over 2, true. But those do not equal 11 over 3. Okay, 11 over 3 is not equivalent to 8 over 2, so that's what this equal sign with the slash through it. So we would say that y over x is not constant. Y does not vary directly with x in this case. So here we're going to do, for each function, determine whether y varies directly with x. If so, what is the constant of variation? So in part A, what we have to do, and remember, our variation equation, direct variation equation, looks like this: y equals kx. So right away we think, oh, I've got to get y by itself. So let's do that. First thing I'm going to do is I'm going to subtract 5x from both sides. So I get 3y equals negative 5x. Divide both sides by 3, I get negative 5 thirds x, or negative 5x over 3. But if I write it this way, it's fairly obvious that this is my constant of variation. That's my k. So this is a direct variation, and my constant of variation is negative 5 thirds. In B, this is already solved for y. So the question is this a direct variation? And when you first look at it, you might think, I don't think it is because x is being divided by 9. Well, we have to understand something. X over 9 is equivalent to 1/9 times x. So this is a direct variation equation or function, and the constant of variation is 1/9. Okay, so understand or remember x over 9 is equivalent to 1/9 times x. If x is in the numerator, you can always pull it out of the fraction. If there's no coefficient on x, when you pull x out of the fraction, the numerator is a 1. Very important thing to remember. Okay, so we have the number of calories. Here's an example and application here. So we're told the number of calories varies directly with the mass of cheese. If 50 grams of cheese contains 200 calories, how many calories are in 70 grams of cheese? All right, so the first thing we need to recognize is that we have two variables, right? We have number of calories and we have mass of cheese. Okay, so let's assign which one's going to be x and which one's going to be y. Well, we're told in the first sentence that the number of calories varies directly with the mass of cheese. So the number of calories is y, the mass of cheese is x. The number of calories is going to depend on the mass of cheese. Okay, now we don't have an equation at all, but we want to be able to write an equation because we are asked how many calories are in 70 grams of cheese. So we need something like this. But we don't have that yet. We don't know what k is. We're not told the constant of variation. But we do have a tool that we can use to find that. Remember, y over x equals k. And in our middle sentence here, if 50 grams of cheese contains 200 calories, we know that k is going to equal 200 over 50. So k in this problem is 4. So our equation for this direct variation is y equals 4x. Now it's fairly simple to find out y, the number of calories, when x is 70. That's 280. So 70 grams of cheese contains 280 calories in this setup when the number of calories varies directly with the mass of cheese. And the information that we're given, we use it to write the equation and then use the equation to solve the problem. All right, in part B, it says, if y squared varies directly with x squared, does that mean y must vary directly with x? Explain. Well, let's check that out. So we're told that y squared equals k x squared. This quantity varies directly with this quantity, right? Differing by some constant of variation. If I get rid of the parentheses here, does this imply that y equals kx? That's what we want to know. Well, I would have to isolate y here, meaning I'd have to get y by itself. And since y is being squared, the only thing that I can do here is I can take the square root of both sides. Okay, but when we do that, that gives us y by itself, which is what we want. But when we're solving an equation and we're using square roots, we have to consider the positive and the negative root here. So we have plus minus the square root of k x squared. Clearly, in this case, we have two solutions for y, so this is not a function. Okay, so miles per gallon is one instance of a direct variation situation. So what we know is that miles miles vary directly with gallons. What that means is, and I'll use M for miles, miles equals K, the constant of variation, times the number of gallons. Okay? So, and again, if we look at the K equals the ratio of M to G, miles to gallons. So what that means is if we were going to graph this direct variation equation, we would have gallons here, and we would have miles here. And if we have no gallons, then we go no miles. That's why all these direct variations go through the origin, because 0, 0 is always on the graph. Now, in this case, it makes it kind of strange because we get an undefined situation, but in the practical application here, 0, 0 makes sense as a solution to this situation because 0 gallons produces 0 miles. Now, depending on what the K is, our graph is going to be some straight line like this. So, but it's going to go through the origin. Right now, here's the connection. The next thing that we're going to talk about is y equals mx plus b form of the linear equation. Right? And if you remember y equals mx plus b form, b is the y-intercept. In a direct variation equation, we have y equals kx. This constant of variation is going to now have a new meaning. We're going to call that slope. There's no other value in this equation, but in a y equals mx plus b sense, think of it as plus 0. That means a y-intercept of 0. Okay? It goes through the origin. So a direct variation equation is a linear equation or a linear function. It's a special type of linear function. And we're going to look at other types of linear functions that are not direct variation equations. Have a good day, folks.